Hello, welcome to part two, Dynamical System. All right, so now our next question. Okay, if let's say I want to model change, okay, how can I approximate change by using difference equation? All right, so our intention is to highlight what is a difference equation. Okay, so first things first, we always need to understand when we talk about modeling, meaning that we want to actually approximate or forecast or try to find what is our future value, isn't it? All right. So normally in a general form, we have a future value. We have right now, we know we are currently reside in a present. So by right, we have the ability to know or to quantify the present value, and then we can see if right now I have a present value and I want to know my future value, it must have a little bit slight change between what I am currently living in and the future. Doesn't matter whether it is a positive change or the negative change, but whatever it is, it must have some changes, right? So that is what we want to calculate or quantify, okay, the change of these particular issues, okay, the future, the present, and also the changes between these two state. All right, so in dynamical system we always consider things as state. All right, so when we want to identify this change, okay, we slightly tweak a little bit of this earlier model, okay, meaning that my change right now is I have the future value minus my present value, right? Okay, that makes sense, isn't it? Okay, so once you have this um, over here, this is actually the difference, all right, the difference between two entity. Okay, so this is what we call a difference. Okay, the difference, the difference equation earlier. Okay, so that is the concept of difference equation. All right, so basically the most important part in identifying or in modeling our dynamic system using difference equation, one thing that you need to really um, focus on is on a discrete time period. Okay, in this particular juncture we didn't talk about continuous, we just focus on a discrete. Okay, continuous is another different element and the way we assess things is completely different. All right, so now we are talking only about the discrete time period. Okay, what does it mean by discrete? Discrete mean, for example, you have state 1, state 2, state 3, state 4, and so on. That one is very clear. It does not has a like I'm not sure, it's a gray area part of things, meaning that I don't bother about the zero point 0.3, zero point 0.4 situation. For example, earlier in the previous video, okay, bacteria doubling, you either have uh, earlier population and then the next step, okay, the next state, then you have the double of your earlier population. Okay, it's clear. Okay, it does not has any zero point 0.3 whatever happened in the half of the state. No, we don't talk about that. Okay, so that is the meaning of discrete. Okay, so when we have discrete time period, then we are able to manipulate or utilize the difference equation. Okay, so now we start to put to make our hands dirty. All right, so if let's say I have a sequence of number, okay, if let's say I have a naught, a zero, okay, a zero, a one, a two, and so on. Okay, and then you can see if I want to look at the difference of this, okay, the difference of my a naught, okay, meaning that it is actually just a1 minus a0, right? Okay, so you can imagine your a1, if you try to tie again with your model, earlier model that we mentioned earlier, okay, so this is just your future and this is just your present. Okay, so you will have this one. Okay, so this triangle is the symbol for difference. All right, symbol for difference. Okay, so this is the first step, and then we move forward to another step. if I have the difference of A naught, then I think I can get a difference of A1, right? Because I have a sequence. Hey, where is it? Oh, sorry. Okay, I have a sequence. Okay, this is my first sequence. Okay, my second sequence, my third sequence, and so on. So basically, I can just build my first sequence and the second and the third and so on. Okay, so that's why you have for now my first A1. The same thing happens, but now my future becomes A2, and then my presence become A1. Okay, and so on. The same thing happens for the rest of the sequence. Okay, now once you have all A2 and so on, whatever happen if let's say we focus on our N. Okay, we stop at N. Okay, no matter whether your N is long or short, doesn't matter. But whatever it is, you can see the difference in here. If I have this, my future values is one step more than my present value, right? So I can safely assume that my difference of an must be equal to an plus 1, okay, plus 1, just one step ahead of my presence, okay, minus my an. Okay, this is the crucial part of building your difference equation. Okay, so now we move forward to example. Okay, the easiest simple ways to understand this is on your simple saving account. But right now, we are not talking about normal way of you saving your money in your bank account, because normally bank we have like yearly dividend. Okay, but to make this easier for you to see, we try to see if let's say you have 1,000, and then if let's say your interest is paid each month, that is like wow, it is a very good a good way, right? If you have interest paid to you in advance on a monthly basis. But let's say this is to make it simpler, all right? So your interest is paid each month, and then you get 1%, okay, interest rate. Okay, so if you have this, you can develop or you can construct your sequence, right? In this sense, okay, your sequence now, you start with 1,000 as your present value, initial states, initial value that you have, and then you calculate easily. Okay, simple calculation. If you have 10%, 1% given to you on a monthly basis, the next month you have extra 10 ringgit. Okay, and then the next month your 1% coming from your 1010, not coming from your initial position. Okay, so that's why you have 1020.10 ringgit. Okay, I mean 1000. 1,210 ringgit and so on. Okay, you can calculate this easily. All right, and this one, and so on. Okay, so what happened to this? You can see over here, we follow the same principle from the earliest formulation. Okay, the first difference that we have is 10. Okay, that makes sense, right? But you now see the second difference that you have now, it's increasing a little bit, right? It increased by 10 ringgit and 10, not 10 ringgit anymore. Okay, so you can see also the next difference for your A2. You will have another extra difference a little bit compared to your previous values, okay, which is 10 ringgit and 20. Okay, you now can see um, these changes is different according to the interest that is passed on to the previous state, not passed on to your initial states, right? Okay, so how can we able to simplify this equation? All right. So if you look at this one carefully, okay, you can see over here. Oh, actually, when I make a little bit changes, all right, this is actually my difference. Okay, this is actually my difference. But you can see over here, this is my future, this is my present, and this is my difference, which is actually, if you notice, this is just your interest. Okay, but your interest must be multiplied with your present. Okay, your present states. All right. I see. I show you again on the previous slide in case you get a little bit caught up with this. Okay, you can see over here. This is your an. Okay, this is your an plus one. Okay, and then this is your an. All right. Okay. And then I think you can work out on your interest rate multiply by your AN. Okay. Because if you put all this, you test from your difference of for your difference of your A2, test difference of your A1, it will fit just nicely. All right. So I hope you do it again. Okay. So once we have this, okay, how to proceed? How to proceed? Okay, you now look at this one. Oh, actually, if I have, okay, I give you earlier just now, an minus an plus 1 minus an equal to 0.01 an. Okay, so in case you get confused again, this is your previous slide, all right? an minus an equal to 0.01 an. Okay, so now if you need to see the future, okay, you need to see the future because by the end of the day you want to predict your future, right? Okay, that's why you just leave your future and it becomes like this. Okay, put all that is not related to your future goes move forward to your right hand side. That's why you have an plus 0.01 an. Okay, so how to transform this information into a dynamical system? A model, all right, a model, a mathematical model that you can play around with, that you can utilize, and you can see how much it grows in a system. Okay, so what you need to do is first you need to write an plus 1 equal to 1 0.01 an. Okay, how come that is so? Okay, because you notice actually this one is just 1, right? Okay, so 1 an plus 0.01 an, it must be equal to 1.01 an. Okay, so now you have only a solution where you have, we call this a constant, all right? And then you have two separate state, okay, the future state and the present state. And then by the end of the day, you have a naught. A naught is your initial state or initial value. In this case, your initial value is 1000. All right, so actually, you can look like this. This is just like this, right? An plus 1 equal to, let's say, r. Okay, I just put one value over here, just a constant, with my initial value. Okay, so this is what a dynamical system looks like. All right, so later in the later part, we are going to play around with r. Whatever happen if, let's say, my r is a value of a positive value, would it have a equilibrium form? How it behaves in a long run? Will my graph becomes unpredictable, or can we predict the graph, or is it a uh, uh, will my graph, let's say, expand exponentially and does not stop, or whether will my graph becomes um, converge into one particular values, or is it just a constant? Okay, so these are all the conditions that we are going to look at in a later chapters. All right, so you have the whole idea of these things. Okay, so now let's say if I want to improve a little bit on my model. Okay, what happened if, let's say, I withdraw 50 ringgit from the account each month? What will happen to my 1,000? Would I still get the value that I get, or will that change a little bit there and then about my graph? And if that change, how will that affect the whole value of my calculation? Okay, so these are some of the example. Okay, if you have this kind of example, okay, the first thing that you need to do is you have to start off with your initial or your standard mathematical model first. In this case, your standard dynamical model, and then later you introduce another disturbance or another disruption over here. In this case, your 50 ringgit. Okay, so that's why you have this. Okay, you still have the same thing. Okay, you still have the same an plus 1 equal to 0.01 an. Okay, but now this is your disruption. Negative 50. Okay, so the rest is just the same. You just introduce this, but the way you solve the model is completely different because now you have another different system, not the same as your previous system. All right, so this one not yet. Okay, so basically, this is what we say about building a difference equation, and then later we are going to move forward and see how does the dynamical system behave if you have different kind of R. R is the coefficient for your n for your an or your states, all right, or your the system inside your full dynamic established dynamical system. Okay, so I hope you understand the concept of difference equation. I'll see you guys in the next lesson.